When we square a number, we multiply that number by itself twice. Taking the square root does the opposite process. It is asking, in a general sense, what number, when squared, gives you the radicand, or the number inside the square root symbol. If we graph the square root of all possible numbers, we see that its domain is greater than 0. That's because, on our number line, for all physical tangible numbers, there is nothing that, when multiplied by itself, gives you a negative number. But when mathematicians challenged this assertion, they came up with imaginary numbers, a placeholder, I, for the square root of -1. Let's look at some of the properties of I. The first one is that if we square it, we get -1. If we cube it, we can utilize some of our power properties, so that would be I squared times I, or -I. If we take it to the fourth power, we get I squared squared, which turns out to be +1. Knowing this, we can find whatever I is when it's raised to a power. Well, how? Well, recall some of your exponent properties. A to the m, in parentheses, raised to the n would give a to the m times n. An example of this is when we take 2 squared squared. Using our power properties, we can say that this is equal to 2 to the 4th, which is just 16. Let's apply this to imaginary numbers. If I to the 4th, which is 1, is raised to any integer power, the result would be 1. If we square I, we get -1. Whenever -1 is raised to an even power, the result will be +1. But if the exponent is odd, then it would be -1. Going a bit further, let's simplify something into imaginary form. Take the square root of -3, for example. -3 is equal to -1 times 3. A property of square roots is that we can now separate this expression into 2 square roots. -1 is equal to I, and there we go. I'll cover adding, multiplying, subtracting, dividing, and other operations in the next video. However, this is just a basic introduction into what imaginary numbers really are.